Okay, so if you're a data professional trying to navigate this new AI era, let's be real. There's one skill that everyone is looking for. It's the skill that literally bridges the gap between everything you know about data engineering and the raw power of large language models. So today, we're going to break it all down. We're talking about Retrieval-Augmented Generation, or as you probably know it, RAG. All right, so here's the game plan. We're going to cover exactly why this is the #1 skill to learn. Then we'll dig into the big problem it actually solves for LLMs. After that, we'll look at the new kind of database that powers the whole thing, see how the entire workflow comes together, and then we'll wrap up with why mastering this is basically your new professional superpower.
So, I know what you're thinking. That's a pretty bold claim, right? The #1 skill? Why is everyone saying this is the most important thing for data folks to learn right now? Well, to kick things off, just check out this quote. It really says it all.
I mean, listen to that. RAG, 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 RAG. He's not saying it's one of the things you should probably look into. He's saying it's the thing. And honestly, this isn't just hype. We're seeing it in the real world. Go look at job descriptions for AI or data engineering roles. They are absolutely packed with RAG as a must-have. Why? Because this is where your deep data skills become incredibly valuable in this new AI world.
You know, for years, we've all talked about the classic data stack, right? You've got your databases, your warehouses, your data lakes. Those have been the big pillars of data engineering forever. Well, you need to start thinking of RAG not as some abstract AI concept, but as a brand new, fundamental piece of that stack. It's a whole new kind of data store that, if you're a data engineer, you're now going to be expected to know how to build and run.
Okay, so why? Why do we even need this new thing in our stack? It all comes down to a simple fact. For all the amazing stuff large language models can do, they have this massive, fundamental blind spot, a huge knowledge gap. And I've got a perfect example to show you exactly what I mean. So look at this comparison. You can ask an LLM, hey, what is artificial intelligence? And it'll give you a fantastic detailed answer. That's easy for it, because it was trained on a giant chunk of the public internet. But then you ask it something specific to your world. How much revenue did our company make last month? And you get nothing. It has absolutely no clue. It can't. It has never seen your private internal company data.
And that gets to the heart of the problem. You got to remember, LLMs are basically frozen in time. They have a knowledge cutoff. They don't know anything that happened after their training date. They have absolutely zero access to your private, real-time data. And what's worse, when they don't know something, they don't just say, I don't know. They often just make stuff up. They hallucinate. And that right there is the exact problem RAG was invented to fix.
So how do we fix it? Well, the solution is really, really cool. It comes in the form of what you can basically think of as a totally new kind of database, one that's built specifically for this new age of AI. And to really get it, we need to understand two key ideas: embeddings and vector databases.
All right, first up, embeddings. This is so important. When you give a piece of text to an AI model, it's not reading it like you and I do. Instead, it turns that text into something called an embedding, which is just a fancy name for a long list of numbers, a vector. But here's the magic trick. That list of numbers doesn't just represent the words, it captures the meaning and the context. It's literally how machines learn to understand relationships in language.
Okay, so if these embeddings are this new type of data, where do you put them? You can't just throw them in a regular SQL database. That's where a vector database comes into play. It's a special kind of database built just for storing and searching these embeddings. And here's the key difference. You don't query it for an exact text match. You give it a vector and ask, hey, find me the other vectors that are most similar to this one in meaning.
I mean, when you step back, this is a huge evolution in how we store data. Think about it. We started with superstructured rows and columns in SQL. Then we got more flexible with things like JSON and NoSQL, and now we're at embeddings in vector databases. It's not just a new tool. This is literally the native data storage for the age of AI.
Okay, so we've got the pieces. How do they all fit together? Let's walk through the actual workflow. How do you go from, say, a huge pile of company documents to getting a smart, accurate answer from an AI?
So let's get practical for a second. Imagine you have a 10,000-page PDF report. You can't just shove that entire thing into an LLM every single time someone asks a question. It wouldn't work. LLMs have a pretty small context window, a limit on how much they can read at once. Plus, it would be insanely slow and super expensive. So what's the first step? It's absolutely critical. You have to break that huge document down into smaller, more manageable chunks.
All right, here it is. The whole RAG process in 5 simple steps. Step 1, you take your documents and you do that chunking we just talked about. Step 2, you take each one of those little chunks and turn it into an embedding. Step 3, you load all of those embeddings into your vector database. Step 4, someone asked a question, and you use that to search your database to find the most relevant chunks. And then, the grand finale, Step 5, you take those relevant chunks, hand them to the LLM, along with the original question, and that's the augment part. The LLM then uses that new context to generate a really good, fact-based answer.
Now that fourth step, the search and retrieve part, that is where the real magic happens. So the user's question also gets turned into an embedding vector. The system then uses this cool math technique called cosine similarity, which really is just a fancy way of measuring how similar two vectors are, to find the chunks of text that are mathematically the closest in meaning to the question. You see the difference? It's not just matching keywords like an old-school search engine. It's finding things that are conceptually related. It's a total game changer.
So, let's bring this all back to you. What does all this actually mean for your career? Why is this way more than just another piece of tech to learn? It's because RAG is your new superpower. It's what the source for this explainer calls your professional flex area.
When you master RAG, you can finally build AI applications that actually understand and use your company's own private data. You're grounding the LLM in real, verifiable facts, which massively cuts down on those crazy hallucinations. And here's the big takeaway. RAG is what turns a generic, all-purpose LLM into a highly specialized expert on your data. You're not just learning a new tool, you're learning the actual backbone of modern AI data engineering. And you get to apply all those core data skills you already have to this brand new, exciting field. This is exactly where data pros have a huge advantage.
So think about it like this. RAG is the new kind of database that finally lets you talk to your data, to have a real conversation with it. So the only question I have for you is, what are you going to build first?